So good morning to everyone for the wonderful presence of the webinar in Intelligence and IoT organized by the Department of Computer Science Engineering in the name of Center of Industrial-Based Internet of Things in association with Computer Society of India, Mumbai chapter. I take this privilege to welcome our Vice Chairman, Engineer 𝐕 Kumaran sir, and our respected registered Dr. 𝐊𝐨𝐿 sir, and our motivated and respected Principal Dr. 𝐊𝐵 Gurumurthy IS sir, and my dear faculties and students. I feel immense pleasure to invite our today's dynamic and young person, Professor Atanu Roy Chowdhury, a founder of Capsule Lab from Kolkata. I welcome you, sir.
Thank you, Professor Jyotish.
A short note about the professor. Atanu Roy Chowdhury is the founder of an Capsule Lab, and he teaches innovation and entrepreneurships at Calcutta University. He was techno-functional consultant for an IoT in digital transformation. He has postgraduate degree in computer science from IIT Guwahati and Harvard University. He is a senior member of IEEE and Computer Society of India, and he has published over 35 papers and patents in the area of IoT and wireless sensor networks. I welcome you, sir, on behalf of the Department of Computer Science Engineering, Arunai Engineering College, TIRUVANNAMALAI. Now I request our principal to facilitate the gathering. Please, sir.
Respected Engineer 𝐕 Kumaran sir, Vice Chairman of Arunai Engineering College, Dr. �R.𝐿, Registrar, Arunai Engineering College, respected Professor and Head of the Department, Dr. M. Jyotish Kumar, distinguished speaker, Mr. Atanu Roy Chowdhury, founder, Capsule Laboratory, Kolkata, Messrs. Cap Group Private Limited, professor and faculty members, and my dear staff and students of Arunai Engineering College. Good morning to one and all. On behalf of the management, faculty, staff, and students of Arunai Engineering College, I welcome you all to the expert talk guest lecture program on intelligence in Internet of Things. That is a webinar. The Internet of Things describes physical objects or group of objects with embedded sensors, processing ability, software, and other technologies that connect and exchange data and other devices and systems and other communication networks, integration of people, things, and interconnected networks in networking systems that connects millions of web products and services. So artificial intelligence is a computer system. Think as a human being to perform tasks, activities that require human intelligence, the ability to gain and knowledge, skills like learning, deep learning, problem solving, duly powered by machines. Artificial intelligence, of course, disrupts and interrupts the present day business and systems. It is highly efficient, and artificial intelligence enabled in IoT creates intelligent machines that simulate smart, sustainable behavior and support planning and decision-making process. Combining AI and IoT's benefits common person and specialist and industries people. By 2025, there will be 70 billion connected IoT devices, and in facility management, embedded sensors, physical objects that process internet data, telecommunication network. And the focus is on ISO 9001 quantitative aspects as well as ISO 9004 qualitative of the embedded systems. Students should learn how this intelligence, that to sustainable intelligence in IoT is enabled to achieve sustainability goals and mitigation risks. That is, sustainable development is a kind of development that meets the needs of the present generation without compromising the ability of the future generation to meet their own needs. So that is should be focused of environmental stewardship, social inclusion, as well as the economical improvement. So present the IoTs and the intelligence should be focused on zero emission IoTs. Loss of biodiversity is there, and climate changes, environmental degradations, environmental pollution, air pollution problems presently, water pollution problems, noise pollution, and the sustainable IoT architecture. You should know the importance of natural resources of earth, that is air, water, land, flora and fauna, natural systems should be safeguarded with the present the intelligence, sustainable intelligence and IoT's connections. So AI is also help to detect, prevent zero-day, that is malware, overcome cyber threats, huge economic losses problems, cyber attack during the digital formations. So environmental impact assessment also can be done by this very good the state-of-the-art intelligence as well as the AIs and the IoTs. So it's a systematic identification and evaluation of the potential environmental effects of the proposed projects, plans, programs, legislative actions with respect to the physical environment, chemical environment, biological environment, biochemical environment, social economical environment, cultural element of the total environment. So sustainability improvement. So you should know about the sustainability improvement in manufacturing systems. AIs and IoTs focus on systematic environmental impact reduction of the products and services in order to efficiently identify and optimally target impact reduction of products and systems. Systematic use is made of life cycle engineering, life cycle assessment methods to quantify and quality respectively avoided environmental effects on different impact categories and the economical consequence of system changes. Sustainability improvement of manufacturing systems, starting from in-depth knowledge of manufacturing process, industrial symbiosis principles, and identify synergies between process categories which allow to eliminate waste streams and avoid losses and excessive energy requirements in conventional recycling flows. So with these few words, I congratulate you to all the students to learn deep learning and the rules as well as the machine learning concept, data science, robotics and automations, which you can learn by yourself as well as with our expert talk and guest lecturers like Professor Atanu Chowdhury, who is expert in this field, especially in the state-of-the-art intelligence as well as the IoTs, towards the sustainable development, which is the need of the hour. That is the development that meets the needs of the educational requirements, that meets the needs of the present generation. See, one generation is equal to 30 years. So in order to meet the 30 years without compromising the future generations to meet their own needs. So which is a very important focus. That is the environmental stewardship, social inclusion, as well as economical development that lead the sustainable education process. So with these few words, I once again welcome all the faculty members as well as the staff members, my dear staff members, and my dear beloved students to learn more focus on this expert talk and gain and apply in your real life as well as create your own state-of-the-art intelligence systems. Thank you very much.
Thank you, sir, for your wonderful speech related to the social connectivity, in what way the IoT-based can able to take over the real world in the name of an Industrial 4.0 in future. So now I request our Professor Atanu Chowdhury to take over the session. Please, sir.
Thank you, Professor Jyotish. I think that was a very, very good summary of where we are in the space of IoT. I spare a few moments to talk about how the intelligence is developing in the Internet of Things. Right? Now, this comes under a new terminology that it has been called today. It is called AI-enabled Internet of Things, or it's been the acronym that is being used is AIoT. Now, in order to do AIoT, fundamentally, we need to understand that there are 3 or 4 things that have happened in the past. First is that a lot of embedded systems are being deployed all around us, and they are creating data by themselves. They are pushing this data to the internet-based systems. That's not new. The kind of applications where from which we are getting data, right, that is new, right? We are seeing deployment of IoT-enabled sensors in agriculture, in fisheries, in industries, in businesses, right, across all domains. So now we are not only getting data, we are getting data about specific processes. And this data can now be mined to understand how can things be done better in a particular application area, right? That's really the value of intelligence in IoT. And today's talk, I'm going to lay a few ground rules. We're going to talk about what are the application areas for IoT. I'm going to delve a little bit into the technology of IoT, right? What are the pieces and what are the technology stacks that are getting created? This will help you understand where you can contribute, where your skills are aligned to the requirements that are there in the market, right? And finally, I'll talk about the opportunities, the kind of companies that are there and are hiring for similar roles, right? So those are the 3 segments that I'm going to talk in, right? So the ground rules, as I mentioned, please, I want this talk to be interactive. I want us to just give, right. I want all of us to understand where we are going with IoT. And so far, when we think about IoT in terms of, yes, there are data flows, yes, there are sensors, but how does it really look like? Right? I wanted to give you some examples, right? So, I want as much interaction. Please feel free to put in your questions and we'll try to get to as many of them as possible, right? So I'm going to break the talk down into 3 areas. First of all is, why should you care about IoT, right? Why do it is an emerging trend, but what does it mean for you as students who are going to be graduating in the next 1 year, 2 year, 3 year time frame, right? And today's talk is going to be primarily based around a street light that became smart, right? A street light that improved its IQ and became smart, right? How did it improve its IQ, right? That's what going to be the meat of the talk. I'm going to start off with a little video. I do not know if it's going to be audible for everybody, but we'll play it.
Every morning just at 5, gotta get up, dead or alive. Hard times in my life, hard times in my life. Every morning right up to 6, don't that old bell make you sick? Hard times in the middle of my life, hard times in the middle.
I'm not sure if all of you got the audio well, but to summarize that particular ad, you're starting to see systems becoming smarter. There are sensors that are getting embedded. In this example, the lady was driving her car. She's tired, but her car figures out that she's moving into the different lane. It identifies that it's an hazard and it shifts lane. Right. So it's a real life example. It's a real life impact that a situation like this has, right? Sensors are getting invisible. They are embedding themselves all around us, and it is having a real cost. It is saving real lives, right? That's what I want you to understand from there. But things did not happen like this overnight. It's taken us many, many years, 40, 50 years to get to this point today. And there's a story behind it, right? If you look at what was happening in the late 1980s, before that, you had mainframe computers. You had one big computer and people would share time on that computer, right? By the 1980s, the personal computer had come into the market. You had companies like IBM, you had companies like Apple, who were starting to launch a personal computer, right? It's a big thing. Somebody who could have a computer in their home was a big thing because they could try out whatever they wanted to, right? The next major change that you saw was by the mid-1990s when laptops started to come into the market, right? So not only was personal computer available to everybody, personal computing available to everybody, those computers were available with a battery, which means that a salesperson could go out into the field, they could go out into a meeting, and they had access to the information that they needed. A scientist could go out to the field and they could gather data from the field itself, right? It's a big step up from what was there in the 1980s, right? By the 2000s, you had feature phones coming into the market, and feature phones were becoming connected on a IP network, right? What we call as the 2.5 generation networks or the edge networks, right? Now, suddenly, business decisions were becoming faster and faster because a decision maker could be reached over a phone, right? You had pagers coming before that, but with the phone, the business decisions really became fast, right? And you started to fuse together this mobile phones with the laptops, and now suddenly you had access to data. You had access to data wherever you went, not only on your laptop, but even if it was on your server, you could access it. By the 2005s, Facebook was starting to come into mainstream, right? Before that, you had Orkut, but with Facebook, what was happening was, for the first time, the boundaries between when people were online and when people were offline, those were starting to get blurred. People wanted to be online all the time. The mobile phones that are coming into the market, they were always connected. They could check for updates in the background, right? And social media, the need to connect with other people, right? That was enabling, that was allowing us to come to the internet more and more, right? So those boundaries were being eliminated. By 2010, the phones themselves were changing, right? The entire screen of the mobile phone was now available for apps, right? You were starting to see e-commerce companies put up their websites over there, starting to create apps, and the whole screen, suddenly you are carrying around a laptop, a computing device with its entire screen, with internet connectivity along with you. And just remember, this is not very long ago. 2010 is probably 10 years ago, right? And we saw this revolution take over the world, right? You started to see apps that were created by essentially startups, right? Which were coming into the market. Companies no longer needed, I mean, today a Facebook is valued at what? Several hundreds of billions of dollars, probably $1 trillion. A large company like a Coca-Cola or a Shell, right, which have been there for the last 100 years, entire Tata industry, right, all the Tata companies put together is probably smaller than the Facebook today, right? So what a company, a conglomerate was able to achieve over 100+ years, a Facebook was able to do that in a matter of a few years. Today, you are seeing more such apps, more such companies come into the market, companies like Zomato, companies like Swiggy, companies like Ola, Uber, right? Which are all powering what we call is the gig economy, right? Where it's an electronic organization where people come together for the purpose of doing a particular task and then they dissipate. You don't have buildings anymore, right? You don't have geographical restrictions for doing your work anymore, right? And all these startups are being powered by these apps which are available on the smartphones, and they are constantly giving us updated information. Just imagine, probably many of you may be a little young to get this reference, but 10 years ago, if you wanted to order something from a restaurant, you would go in, place an order, wait for the package to be for the order to be created, and then pick it up and come back, right? It would take you time. You were willing to give it that time, but today you are not willing to give it that time. You want to know when the order was placed. You want to know when your pizza went into the oven. You want to know when the toppings were put in. You want to know when the package was picked up. You want to know where exactly the driver is with your food. You want data available to you every 5 seconds, every 10 seconds. And this would not be possible if we did not have sensors that are getting embedded, right, all around. The smartphones that you see today already have GPS sensors, already have altitude sensors, light sensors, temperature sensors, right? All of these various kinds of sensors built into the phone itself, right? So you're starting to see more and more sensors come into the market, into the system, right? You're seeing cashless smart city environments. Today, if I were to go even to Bangalore, right, you can pretty much know when the next bus is due at the bus stop, right? You can pretty much know, you can pretty much pay for any of your services over an UPI system, right? So you're already starting to see the emergence of these cashless smart cities, which are a visible reality today, where a lot of these interactions are happening over the internet, and this is being enabled by the by embedding more and more computing infrastructure all around us, right? You have to understand that with the smart cities, what is happening is that there is an exponential increase in digital interactions, right? Due to two main reasons. One is that there is an increase in the per person usage of in the number of digital services that are available to an individual, as well as the number of individuals who are coming on the internet right now, which is why both of these factors together is increasing the overall number of transactions that we are doing on the internet, right? Not only we, when I say we, I'm referring to humans. You're starting to see a lot of these interactions which are happening, but which are being initiated by machines themselves, right? When you are walking in front of a shopping mall, the doors are opening and it is actually counting how many people are walking in, right? Which is reporting that data back to the mall operators saying that this is the traffic footfall that is happening. So you are starting to see not only human to human interfaces, you are starting to see human to machine interfaces as well as machine to machine interfaces, right? Just like computers came into our ecosystem about 20-30 years ago, and now it has penetrated every aspect of our life, be it in our railway ticket booking, or in hailing a taxi, or in ordering a food. Similarly, IoT is something that is penetrating across domains. Right, we find the use of IoT-based systems in smart cities. Right, these are government-sponsored initiatives usually for the benefit of citizens. We are starting to see the emergence of IoT in industrial process improvement, which comes under Industry 4.0, and that is helping us improving our manufacturing capabilities. In fact, only yesterday it was reported that India, for the first time, crossed more than $400 billion in exports. Never before has our country been able to export that much, right? That is happening because new industries are starting to manufacture in India, right? We see the emergence of IoT in enterprise IoT, which is where there are various businesses which are starting to use IoT, whether it is for their attendance monitoring systems, whether it is for their safety monitoring systems, whether it is for cooling down their server rooms, right? You are starting to see businesses start to use IoT. And of course, with the emergence of all the smart devices, be it a smart light or a smart fridge or a smart doorbell, we are seeing end consumers starting to adopt IoT as well. Right. So today I'm going to delve down deeper into one of these aspects, which is around what we call smart cities. Now, if I break down this smart city, what does it look like? IoT really looks like a lot of infrastructure, right? What does this infrastructure look like? Well, you have what we call our field devices. These are sensors that are put out there on the field, right? These are devices that needs to be installed. Today, if you were to order, for example, if you were to order a broadband connection in your home, right? An Airtel person or a Reliance person is going to come home and is going to install a modem, draw the line, right? Set it up for you, right? That's what is called a field engineering, right? These devices which are there, whether it is to monitor temperature or heat or motion, right? These have to be installed, right? And this is where there is new scope for employment. These devices are connected through what we call is a field gateway, an aggregating device that gets information over this local network, passes it on to an edge gateway. So think of it like a hotel. You might have a door sensor or a temperature sensor in every room, and you have one field gateway on every floor of the hotel, and then you have an edge gateway on the property, right? Where does data go from here? From here, the data will go to a cloud gateway, right? Which is a publicly accessible location on the internet where all the data from the devices can be pushed into, right? From here, it goes to an application backend, just like the applications that you see today. You have used a Swiggy application. Somewhere it is getting data from every rider who is delivering, every delivery boy who's there supplying the orders. Data from their mobile phones are going to this application backend. And it is serving this information to you over a mobile phone, over a web application, or as a report, right? So IoT is a lot of infrastructure. There are viewing devices or human-machine interfaces by which we interact with this whole system. There are web servers, just like the web servers that you use to serve an e-commerce application or any other application that you have out there today. There are cloud services that are getting integrated, and you are leveraging a lot of these cloud services to do time series data, to see how the data, the reading from a particular sensor is varying over time. You are using third-party systems, like, for example, your application may allow you to log in using your Google email ID, right, or your Google account, right? So that is a third-party systems integration, right? Swiggy shows where your driver is on a map, right? The map is provided by Google Maps. Right? So that is again the example of a third-party system. So, but what you can understand from here is that IoT systems are heterogeneous, right? And it has a diversity of devices. It has sensors, right? As I showed you over here, it has sensors, it has routers, it has gateways, it has cloud systems, it has servers, it has web applications. All of these things are there. But what is different with IoT is that, unlike traditional applications where all of them are general purpose computing devices, these IoT devices are different from each other, right? They are different with respect to their ability to compute, their ability to sense, to communicate, store, and their power requirements. Some of them are server grade, large machines. Some of them are running on less than 1 microwatt of power. Some of them are running today, your laptops are running with 4 gigabytes of memory, 8 gigabytes of memory. Some of these sensors are running with 4 kilobytes of memory, right? Your laptop is able to talk over Wi-Fi, it is able to talk over LAN, it is able to talk over Bluetooth, right? Some of these devices may be able to talk only over Bluetooth, or they may be able to talk over emerging radio technologies for longer distances, right? Low power, wide area communication technologies. That is why the technology is changing, right? Because each of these devices have different capabilities. Because of this, what is happening is that there are new jobs that are getting created, right? Unlike traditional applications where you looked at only a front-end design, a web development person, right, or a mobile app development person, now along with those application developers, right, along with those UI designers, mobile app developers, front-end developers, back-end developers, right, you are starting to see a lot of these new roles that are coming out in the market, right? There are roles of field engineers, there are roles of control room operators, there are roles for machine learning developers, there are roles for cloud DevOps, people who are managing that entire cloud. There are device original equipment manufacturers who are making these devices. They are creating new opportunities, right? There are semiconductor companies who are making chips that are being used by these device manufacturers, right? So they are opening up new opportunities. So overall, IoT means that there are new opportunities or new kind of companies where you can start applying for jobs even with a computer science background. Traditionally, the core companies, like companies, people who are coming in from an electrical background, from a mechanical background, right? But what were the kind of core companies they would have gone to? They would have gone to an ABB, they would have gone to a Schneider, they would have gone to a Hitachi, a Fujitsu, a General Electric, a Siemens, right? And all of these companies today are investing very, very heavily on IoT-based solutions to manage their field deployments, right? Today, an ABB, a GE does not, the GE motors that are supplied on airplanes, on Boeings and Airbuses, they are monitored remotely, right? The quality of those machines are monitored remotely, right? That is the application area, right? That is where new opportunities are being created, right? I told you that I'm going to speak a little bit more about IoT in smart cities, right? So let me delve in deeper. What are these smart city applications? See, upfront, I can see so many applications. I can use it to monitor street lighting. I can use it to know where a parking spot is available and make a reservation for a parking spot. I can use it to control traffic lights remotely based on the traffic flows. I can use it to dispatch ambulances to where they are needed. Right? I can use it to collect waste from wherever the dustbins are full. I can use it for letting people know when a bus is available at their bus stop so that they're not spending time waiting for the bus. I can use it to automatically meter whether it is a water bill or an electric bill, right? I can measure I can get the meter readings done remotely, right? Even tax filing and all that all can be done remotely. That's an example of digitization, right? Now it's good to kind of say that yes, all of these are possible, right? All of these at a superficial level, there are applications in each and every one of them, right? But for a company to flourish, we need to understand what are the deeper implications of IoT in each of these technologies, right? So let me take one example out of this and go deeper into it, right? So let me take the example of street lighting, right? And that will bring me to my next section of how the street light improved its IQ and became smart. Right? At this point, do I have any questions from the audience? I'm not seeing any questions on the WhatsApp group. Let me just quickly check. No, I don't see any questions on the list either. Okay.
Sir, I think students will join over in the auditorium. They have collecting the questions. Maybe at the session ending, they will post the questions, sir, actually.
Absolutely, absolutely.
Yeah, thank you.
Right? So let's go a little deeper in terms of where, how does let's say a simple street light, right? How does it improve its IQ? Right? Now, many of you have seen a street lamp like this, right? It's a halogen bulb. It's called a HPS street light, right? And nowadays, what happens is somebody is going to go out there every evening and turn on a switch. Right? When they turn on the switch, the lights will come on. These bulbs, which were essentially halogen bulbs, and by halogen bulb, essentially the principle on which it operates is basically saying that a piece of filament will glow, and it is kept in an inert environment, right? So whatever, as it glows, it kind of gives out energy in the form of light and heat. A little bit more heat than light because it is coming out of incandescence, right? And these lights are not very good at lighting the streets, right? Because as you can see over here, wherever the light poles are, you will find a high luminescence reading, about 1.4, and quickly kind of drops off. So there are the shadow areas that you will see, and the light kind of gets concentrated around this, light under the street lamp, right? So this kind of a system where a person is going out every evening to switch on that light, I really cannot say that it has a lot of intelligence. So in my IQ meter, I call it as an IQ 0, right? There's no IQ over here. Right? So the first changes that we can make to this system is, let me change the lighting technology itself, right? Let me move from a halogen light to an LED light, which is a light emitting diode. By virtue of being a light emitting diode, right, it has to work on a DC voltage. It has to. So I need in making this new light, what am I changing? I'm changing from an AC circuitry, a 220 volt AC, to a power conditioning circuitry, which is changing it back to DC, and then I'm driving this. So I have some power conditioning circuitry that has gone in. The LEDs are extremely efficient because most of the energy is getting converted into light rather than heat. So you can find that the drop in lighting levels is actually less steeper. You get more light out of this system. So definitely, the LEDs are more efficient than the previous generation. But in doing so, what has happened is, a person still needs to go out and switch on these LEDs, right? So in my IQ meter, the score does not really increase. It is still at a 0, right? Of course, I can make this thing a little bit more efficient by putting on a solar panel on top of this LED light, right? But that kind of brings in its own cost, because now you have to bring in the cost of the solar panel, the inverter, the battery, right? And in some places that may be more viable, but wherever there are there's electric supply available, you might choose to use the existing lines. But what we have done with this process is that we have brought power conditioning circuitry and digital electronics inside this frame, or what we call as the luminaire, right? Now, let me represent this luminaire a little differently. This is my new visualization for a luminaire. If I have this luminaire, right, and what can I do with this? I can build a mobile app, or I can build an application by which I am going to every time I'm installing a new app, I'm going to mark its location on a mobile app. Right, I can do that. That is something that is possible with our existing system today. And with this existing system, wherever there are workmen who are installing it, they go ahead, they install it, and they mark the location. The location address they're getting from their phone itself. It goes into an IT application, and pretty soon I will have this map view. What does this map view allow me to do? It allows me to see where exactly are my lights, right? Where exactly are my street lamps, right? And it helps me plan my IT workflows. It tells me, if somebody is if somebody notices that a bulb has gone off, they can call the service center and say that, look, the bulb in front of my house is not working. Street lamp in front of my house is not working. They can report a complaint, and the IT workforce can look at this data and say, yes, this bulb is not working right now. This bulb is not working right now, right? And this becomes a tool to visualize which parts may need maintenance. This kind of an application you can build with our existing technology today, right? You can build this as a web application, right? And when we talk about web applications, we talk about a full stack application. You can represent this for those of you who are interested in application development. You're very familiar with what we call as the MVC model of development, right? Where we have a model, we have controllers and views, right? We have the field devices. The way this works is your controllers are mainly based on a PHP based server, or an Apache based server, web server, or a Python based, or Ruby on Rails. Node.js is a good technology to use for building your controllers. And most of the data is stored in SQL based systems, right? Whether it is a Postgres or MySQL or SQLite, right? And for the front end, you might use Bootstrap, you might use basic HTML, JavaScript to build the front end, or you may use Bootstrap, React is there, Angular is there, Vue is there. So these are all JavaScript-based technologies that are there to give a better touch and feel, a better user experience, if you will, right? And accordingly, if you are building an application that touches all these layers, you will hear these words like LAMP, mean, MERN, right? LAMP standing for Linux, Apache, MySQL, and PHP kind of a technology stack. Whereas mean stands for a MongoDB. I'll come to MongoDB in a little bit. Mongo Express that you see over here, AngularJS, and Node.js. That's the technology stack that is getting used. Or you could be using React instead of Angular, so you call it a MERN stack. So you will find a lot of job openings where they're saying that they're looking for a full stack developer, a MERN stack developer, a mean stack developer. Now you know what that means, right? Now, coming back to my application, right? Now, the change that I want to make to this application is if I put a little sensor on each of these street lights, right? What am I going to ask this sensor to do is it's a relay. It's a small relay, so that can switch on or switch off the power supply, right? So from my IoT application that I had built previously, I can now send a command to this particular receiver over here, right? So this is the receiving device. It receives it and it says that, okay, am I going to turn on a relay, or am I going to turn off a relay? Accordingly, the power is switched on or switched off. It may also support a dim command, right? Which allows, because this is a digital, this is now a digital technology. I can use, those of you coming from electronics background will understand this. I can use power with modulation, right? PWM, to dim the pulses and reduce the light, right? If I just do this much, if I can do just this much, then I can develop my application further, and I can switch it on or off from my application here itself, right? So I have now the capability to do remote operations on this. I also have the capability to write a program that will turn it on at 6 o'clock in the 7 o'clock in the evening, and switch it off again at 6 o'clock in the morning. And I can set different dimming levels for it, right? So I can set a variable schedule. I can do the schedule based on not only the time of day, I can do the schedule based on the month of the year as well, right? I can do it based on seasons as well, right? So you'll all agree with me that this particular capability has slightly more intelligence than the previous one. I'm not saying it's a whole lot of intelligence, but it has slightly more intelligence into it, right? What else can I do over here? I can probably integrate it with the weather APIs, right? With a third-party weather API that we are getting from, say, weather.com or AccuWeather.com. These are third-party companies who are monitoring weather, and they give you an API, and they say that you can connect to it. And if it is cloudy, if the weather says cloudy, then I override this schedule and make the lights glow more, right? So I can either do the schedules which are predefined, or I can now start to do weather-based automatic dimming of the lights, right? Clearly, my light meter, my street light is becoming a little smarter, right? What else I can do? Well, I know exactly how long the device was expected to be switched on, right? And since I know when I gave it the command to turn on and when I gave it the command to turn off, I can start to estimate how much energy this street lamp is consuming, right? So that is an additional piece of information that I now have in terms of the energy consumption estimate, right? At this point, it is an estimate because I have only one-way communication between my cloud and this receiver, right? Why do I have one-way? Because it is cheaper to do a one-way communication. Of course, if I want to do bidirectional communication, it is also possible, but now I'm talking about, changing this arrow to a two-way arrow, right? So it is not only just receiving commands, it is also able to send me some information. What is the first information that it should send me? Well, it can tell me when exactly did it actually turn on. I might have given it a command, but there was no power supply, so it did not consume energy. But now it can precisely measure the amount of energy that was being consumed and report the usage and the energy consumption, that was the actual usage data, right? It comes to my application. So because I have bidirectional communication, I now have control, plus I have usage monitoring, right? And now I have actual data from when did it switch on, when was it consuming power, right? How much power did it consume? And in the morning, again, it is switched off, so it is not consuming power anymore, right? So this information allows me to do some more things. Like what? Now I can measure which vendors' products are doing better, right? If most cities will have 3 or 4 or 5 empaneled vendors from which they're buying their bulbs. Now I know exactly how much power each of those vendors' products are consuming. So somebody could have sold me a cheaper bulb, but it consumes more power, right? So in the longer run, the cost of the bulb plus the cost of operating that bulb may actually be higher, right? So with a vendor product scorecard, it tells me precisely the how much which vendor I should go with. It also tells me which vendors' products are they are getting damaged sooner than the other vendors, right? So that way it allows me to make a scorecard and identify who are the right vendors for the city, right? Now, if I know how much energy this is expected to consume, and I am observing a higher energy consumption from a particular street lamp, pole, right? I know that there is pilferage that is going on, right? The application gets to know that there is energy that is being taken out from this system somehow, right? So it helps me understand, it helps the city understand if there is energy leakage or energy theft that is happening, right? Now, in order to do this, in order to get this bidirectional control going, you need to build a particular system over here, right? You need to have this sensor will just not get there. It has to be built. So there are companies which are going to build this controller box, right? And that is where you start the role of embedded developers come in IoT, right? So if you look at embedded development, all these field devices that we had talked about earlier, be it the edge gateway, be it the sensors, right? All of them are being developed by various companies. And as an embedded developer, if when you are going and joining these companies, you are working on how do you get a sensor to connect with a particular low power computing chip? How do you get the data out on the particular radio, right? So how do you write programs which are low power, which can operate in low computing environments, right? So these are mostly programs that will be written on C. We'll be using environments like an ST32 or even lower powered microcontrollers to run a lot of these devices, right? And the second level of programs that many of you will be writing is at the gateway, at these gateway levels, right? Where on one side of the gateway, you are talking to the internet. So you have the complete internet protocol stack, whether it is HTTP over TCP, over IP, over Ethernet or Wi-Fi, right? So that's the typical OSI stack that runs in most of our computers, in most of our phones, right? But on the south side of this, you need the IoT stack, the communication protocol that is needed to work with this low powered devices, because these poor chaps have very limited memory, so they cannot really run a full-fledged HTTP stack. They cannot run a full-fledged web browser or a full-fledged communication stack like TCP, right? So you might want to use something that is more suitable over here. Coming back to our story, right? If I have this capability of doing bidirectional communication between the devices and the cloud application and this IoT application, why should I use it to monitor just the energy consumption, right? I can use it to start measuring other things as well. What kind of things? Well, I can start to measure ambient conditions, right? What is the local temperature over here? Right, that is an ambient condition. Right, I can look at what are the local light levels. For example, if my street lamp is placed in a location where I have a few houses around which already have gate lights, right? In that case, the street light does not need to glow at its optimal. It can save power by glowing at a lower level, right? Or if it is in a particularly dark region, right, then I need to glow at full capacity, right? So I can do ambient light-based automation if I know the light levels on around this street lamp, right? I can even create a map saying where are the lit areas in the particular locality. I can look at sound levels and toxicity levels, right? I can look at if this is in a noisy place and build a noise map. That is essentially I'm able to now collect data about urban pollution, right? Whether it is in terms of light, sound, or air quality, right? I can provide this data to the urban planning department saying that, look, these are areas which are very, very noisy. Why don't, because this is next to a highway or for whatever reason, why don't you consider constructing some noise cancelling walls around this highway so that people are, the pollution level, the noise pollution level for people can be reduced, right? By doing this, I'm starting to create a collaboration between departments. This was the electric supply department, the city department, the city municipality. Earlier, it did not really interact with the construction department, but now they have data on the basis of which they can create a collaboration, right? So with IoT, that is one of the biggest advantages. You start to build models, you start to build systems which are now bringing departments together, right? What else can I do with this? Right, I can build heat maps and building guidelines. I can look at temperature and humidity levels, right? So what happens is if you have areas where you have glass buildings on either side, they tend to reflect the sunlight and create what are called heat traps, right? With heat traps, I can now, if I have this information, then only I can go to the civic department and tell them that, look, this place is already getting a lot of heat trapped inside. We are not going to give permissions to buildings with glass facades in this area, right? So there is something that the city can respond to, and it's by responding to that, it benefits everybody in the city, right? It allows us to monitor air quality index. It, at times, if there is a lot of sudden noise that is coming from a particular street, this could be input for the police, right? It could be an input for the local law enforcement to go and check out why is there suddenly so much noise in a particular area, right? Is it a temporary thing like a marriage procession or something, or is there something else that is going on over here? Right. So clearly, a little bit of sensorification is allowing us to gather a lot of data, which can be used to make the system smarter, make turn the city traffic, the city lighting control system, the city street lighting system into an effective data gathering tool. Right. It is making it a macroscope. I'm sure at this point, all of you will still agree with me that when we do this sensorification, the IQ of my street lights are going up, right? What else can I do? When I'm talking about, these insights for enforcement agencies, I'm talking about being able to monitor these sound levels, being able to monitor this light levels, right? And when I monitor, to know that something is above normal or below normal, I need to have a comparison with whatever had happened before this, right? So there are already tools that are available, right? Amazon, for example, has a service called Amazon Forecast, which allows you to do this kind of regression models, right? Not only just Amazon, there is a whole bunch of services that are available today, which you can use. If I take an example of that, what are the technology stacks and the machine learning SaaS services that are available? First thing we'll notice is, apart from the SQL-based databases, today we are starting to use a whole bunch of different kinds of technologies over here. You're seeing MongoDB, which is a document database. You can store data as documents over there. You have Cassandra, which is a time series database. So every new data point that comes in with a different timestamp gets to make its own record, right? If you have images that are coming in, you might want to store them on a low-cost service like Amazon's S3 service. You have a database with APIs available from Google called Firebase. Apache Spark is a tool that is a data streaming tool that you can use to split the data into multiple streams and run different filters on each of these different streams of data that you are getting. Right. From the programming side, Python is used extensively in terms of building the machine learning frameworks. Right. There is, of course, MATLAB and its open source variant called GNU Octave. You're building a lot of these applications in R. In some cases, you might be able to build them with Java or in JavaScript itself. And of course, if you're using C, C++, it gives you very tight, very low footprint models. You typically will use C or C++ if you're looking at building this machine learning algorithms on the embedded device themselves, right? Along with this, you also have the machine learning as a service that is available to you across various vendors, right? Be it from Amazon. Amazon offers it under the name of Amazon SageMaker. Azure offers it. Microsoft offers it under their Azure machine learning platform. Google offers it under their Google Cloud AutoML platform. IBM Watson offers it under the Watson brand. So you have all the major cloud vendors providing you this machine learning services under various brand names. If I go a little bit deeper inside Amazon, you'll find that the SageMaker again has multiple components. It has Amazon Comprehend, which is used for natural language processing. You have Amazon Lex, which is used for building conversational chatbot, something that is used to build Alexa. Amazon Forecast, I talked about earlier, is used to build time series forecasting models. You have a tool called Amazon Recognition, right? Recognition with a K for image and video analysis applications. You have Amazon Poly, which is used for text-to-speech conversion, right? So you have multiple tools that are available to you, and you can build your, projects that you are doing. You try and integrate these tools into your project so that you have better and more complex projects that you can implement, right? Because if you are doing this, you can build models that allow you to not only react to a particular environment, it allows you to predict about potential failures, right? With this machine learning tools, with the data set that you are getting, you learn from the data set, and then you start building models which will help you predict, right? For example, if you are starting to build predictive maintenance systems, given that we know about a particular vendor's data usage, energy usage, we know a particular vendor's mean time to failure, we can start to predict what are the kind of failures that we are going to see in the street lamps. So even before the street lamps fail, I can now plan a route, I can plan a maintenance schedule around which are the, I can create this maintenance schedule for particular workers and let them know that, these are the bulbs that are likely to fail. You go and replace them. So there is no disruption of service to the citizen, right? You're making your own maintenance schedule, right? Why? You can now feed this maintenance schedule directly into the maintenance app, which the replacement team is going to use. So they know exactly where to go after a particular maintenance is over, right? This will again save you time because you're not having to go back to areas which you have already covered. It reduces time wastage of the workers who are going out and making these replacements, right? Also, you can do replacements of bulbs which are nearing their, which are kind of nearing their time to, which are kind of nearing their failure time, and you can take them out and put them in areas where they might be used less often, right? What else can we do? Right, we can start to do object enumeration, right? So far we have been dealing with sensor data, and we have been seeing how we are using this sensor data to predict about a potential failure that can happen, right? Now, what if I add a little camera on each of these light poles? What will that allow me to do? It will allow me to now, first of all, take images so I can get a live feed, but sending back live data may require additional bandwidth, right? If I don't have that much bandwidth, then what can I do? Then I can run image processing algorithms on the camera itself, right? And I can use it to count. I can use it to count people. I can use it to count objects. I can use it to count number plates, right? So that allows me to kind of measure what is the citizen movement density. If I have a street lamp in an area where I'm observing a very high movement of people, then the street lamp should be on as much of the time as possible. However, if I'm not observing, or if I've historically not observed a lot of people movement under a particular street lamp, then I may choose to turn it off when I'm not detecting any movement. Right. So clearly that allows me to measure or count how many people. Is there a real utility for the street lamp being placed where it is, right? How am I doing that? Well, I have my image processing algorithms, which I can use to do object localization, and then I can do object detection, and then I can do an instance segmentation to count the different types of objects, right? This allows me to create what I just mentioned, the utilization scorecard, right? What is the utility of a street lamp, right? Is it really serving a purpose by giving light to citizens who are walking, who are in that area? Or is it a completely useless street light? It serves no purpose because nobody ever walks down that road, right? So it allows me to make these kind of scorecards. And I can do a light rotation schedule, which means that if I have places where the utilization score is low, then I can rotate out the bulbs which are more likely to fail in these locations. Because then what will happen is, with a fewer number of bulbs, I can now cover a larger area and have a lower risk of failure, right? What else can I do? I can do traffic segmentation. Right. I can do what kind of traffic really moves around in that area. Is it heavy traffic, light commercial vehicles, or is it more of four-wheelers, or is it more of two-wheelers, or is it people who are just cycling, right? So I can now start to do people count. I can start to do object segmentation and classify the kind of traffic movement that I'm observing in a particular area. I can use it to start reading even license plate numbers, right? Identifying which vehicles went through a particular area, so that now I'm not having to rely on the shape of the vehicle. I have very precise information on movement that is happening over here. Right? I can even, I can be fancy. I can even start looking at city infrastructure theft detection, right? If I can count that an object is a bench, and every day morning I check the bench is there, one day I find that the bench is not there, right? I can even detect that, right? That there has been a theft, or this thing has been moved from a particular location, right? Everybody with me so far? What else? Because this is now whetting our appetite. It now is telling us that if we can do so much, what else can we do out of it? We can bring context awareness, right? What does context awareness mean? It means that now I am no longer, I no longer want to look at the data that I have from my particular sensors themselves. What if different street lights, which are neighboring street lights, could talk among themselves, right? What information can I do out of that, right? What if I can do follow me lighting, right? Follow me lighting is essentially where a street lamp detects that a person or a vehicle is approaching it, right, and switches on, and then it detects that the person may be moving in a particular direction, and then the next light switches on. This is now communication that is happening between the street lights themselves, right? The data from a street lamp is going there. It is notifying that, yes, there is a person who is moving underneath. Another sensor picks up a person, says it is now, the person is moving in my range. So I can send a message that you switch on now, right? I can keep on passing this message to successive street lamps so that they illuminate the path for a particular user, right? Or they dim down when the person is not walking underneath it, and then they brighten up when the person is going underneath, right? So this is called follow me lighting. If I have higher bandwidth that is available, right? If I really have higher bandwidth that is available and I can do video transfer, right? Then I can now observe how many people are aggregating under a particular street lamp, right? Is it groups of 3, 5, 10 people, right? I can start to create these groups. And if I can create these groups, I can now put an ad space over here, which is now going to serve context sensitive ads, right? So if it is, one person who is walking by in a rush, right? I want to tell them, hey, your next bus is available at the bus stop in 5 minutes, right? If it is a group of 5 people who are casually walking by, a group of friends who are walking by, right, I can tell them, hey, there's a coffee shop down the corner, right? If it's a bunch of children who are walking by, I might actually send a signal to the next traffic light saying that, hey, there are children coming. You might want to turn the traffic signal red, right? So now if I have that service available, if I have video streaming that is capable, I can do this detection in real time, and I can start to do context aware advertising, right? Advertising that is targeted towards the group of people who are currently joining in, right? What else can I do? I can do push advertising. What is push advertising? Push advertising is I can now connect say for example, a Bluetooth beacon onto this street light. I'm getting really fancy over here because, well, I'm increasing the IQ of my street light, of my smart street light. If I put a Bluetooth beacon, then as people walk by, I will be able to push advertisements. I will be able to push information into their phones from advertising information into their phones as they're walking by these street lamps, right? I can do speech and voice recognition. even more interesting, right? I can use this space because the street lamps are public property. You can have people from different parts of the country who has come to a particular city. They may not be particularly aware of the local language. So they can use this public infrastructure to talk and ask about, questions about the locality, right? For example, somebody could come in and ask the street lamp, hey, when is the next bus to a particular place going to come over here, or how do I go to a particular place from here? And they can ask it in their local vernacular language, right? You can have what we call our public translation services. That is available, where you have somebody speaking a foreign language who can interact with the street lamp and ask it specific questions about when is the bus arriving, how far is the nearest hospital, right? You can ask it location aware queries, right? Location aware queries means questions which are how far, where kind of queries. You can ask time aware queries, like when is a particular bus coming, right? So you can do time aware queries and location aware queries from these street lamps itself. What else can I do? One more thing that I forgot to mention over here is, in order to do this, you find that we are able to use a lot of services that are already present. We can integrate with Google Assistant, with Alexa services, with Cortana from Microsoft. You can integrate with Siri, and they provide you APIs, right? They provide you these APIs as software services, which can integrate onto your cloud. So when somebody speaks into this particular receiver over here, that keyword is sent over to the cloud, and from the cloud it is getting to the natural language processing system. It is getting converted. The answer is getting created. The answer is getting converted into the local language, into a language that the person will understand. That voice packet will come back through the cloud into the street lamp and will get played back by this system, by the speaker system, right? What else can we do? Right? We can do gesture recognition, right? How can we do gesture and intent recognition? Because gesture is nothing but a series of images one by one, right? When you talk about a video is 32 images per second, right? Or we can have a lower frame rate. So instead of looking at doing a bounding box on just one thing, we are now tracking across multiple frames and identifying that this is a particular action. Somebody is maybe, a hand up becomes a gesture for I need help. Right? Somebody is far away from the field, so their voice may not be heard. So they can put up a gesture saying that I need help. And the system can now recognize that, can translate that as a call for help, and forward that particular video to a law enforcement situation, right? To a law enforcement control room, right? I can do weapon recognition, right? I'm getting really fancy here. I'm getting into the realm of solutions which are not there today, but are solutions that are likely to start to come into the market, and demand for these kind of systems will only increase over time, right? I can do weapon recognition. I can do mob identification if a bunch of people have gathered together with the wrong intent, right? That's, I'm getting from just object detection to a higher level function of trying to understand what people are trying to communicate. What is their intent? Why have they come together, right? And automatically I can do auto alarm modes, right? Converting that signal into something that is more actionable, right? I can do this from one such smart street lamp. I can aggregate the information from multiple such street lamps into what we call our context aggregates, right? We are now not taking the value from just one street lamp. We are taking the value from multiple street lamps spread out throughout the city. And that is helping us understand, understand and prevent crime, right? It's getting us into crime prediction. It is getting us into areas of epidemic arrest. If I am seeing a bunch of people, not wearing a mask, moving around all over the area, or in particular areas, or in particular streets, or in particular lanes, it gives me very good insights that this is an area where a potential outbreak can happen. Right. So last year we already saw a number of countries starting to deploy these kind of infrastructure, especially in China, where we are looking at putting up cameras on public infrastructure in order to arrest the growth of epidemic. Right. Even at this level of aggregation, if you notice, that has brought me to an IQ level of 10 on my IQ meter. Right. In this discussion, so far, what we have covered is we have tried to answer the question that what is the value provided by smart street lights? And if I look into it, how has it been able to value? When we changed from the LED lamps to a renewable source, right? When we changed our lighting infrastructure from halogen bulbs to LED lamps with a renewable source, we reduced the number of defects. We reduced overproduction, and we reduced the kind of inventory that is needed, right? With the IT systems, we reduced transportation costs. We reduced the number of times people had to go and change and inspect a particular lighting infrastructure. Right? We reduced the waiting time for new stocks to come in, for stocks to be replenished. Right? With location visualization, we were able to do this a little better. With scheduling and remote control, we were not only able to reduce the transportation cost, the excesses of motions, the excesses of waiting around for things. We were also able to reduce the overproduction that was necessary, right? Because we were using the lights much more diligently. Each of the lamps that had been bought by the city was lasting us longer. But with the next generation of services, right, with usage monitoring, with sensorification, with predictive maintenance, we are starting to see new kind of services that did not exist before, right? With object enumeration, context awareness, right, we are starting to see new services that does not exist in the current generation of street lighting solutions, right? And that is the value, that is the advantage that IoT and machine learning, together with machine learning, builds to the system, right? Today, I took the example of only street lamps, but the same use cases may be true for whether you're talking about identifying where parking is to be, identifying a parking spot, or traffic signals or public transport. All of those areas will have a number of new values, a number of new areas that will be unlocked with the emergence or with the adoption of IoT and machine learning over there. Right. Remember, machine learning does not work unless you have the data with which your machines can learn, with which your algorithms can learn. So first you need the data, then you are able to build your models, and then you are able to use those models in order to make predictions. Right. Even with all of these new intelligence, you have to understand that what we are talking about is still called generalized AI, right? With generalized AI, the IQ is still at, we got to a level of 10, right? Humans operate at IQ levels of anywhere between a 70 to a 110, 120. That's the moral, ideally the average should be 100, but we go around in a margin around that. Right? We call it generalized AI because it's still us humans who would have to write the algorithms to train a particular model, right? We are doing what is robotic intelligence. We have built the rules, which is allowing, rather than becoming just rule-based, where it is a basic rule engine. We are taking a decision based on a value being higher or lower than a threshold, right? We are now able to do more probabilistic searching of the solution space, right? So we are evolving from that intelligence space, but we have still not been able to get to a space of generalized AI, right? So the systems that we are building today, there is a lot of capabilities that AI can still bring in. They are not completely autonomous systems. They are not systems that will threaten human intelligence. They're not performing at that level, right? they are performing at a level which is somewhere between robotic intelligence to the intelligence levels are probably that of a young child, right? That is what we are able to achieve today. But down the line, as we deploy more and more computing infrastructure, as we come up with better ways to process a lot of information. Today already you are seeing neural nets, neural networks that are built not as software, but they are built as hardware chips themselves, right? Earlier on, when we were doing our AI and neural net programming and all of that, we used to build each of these networks as a software class, as a software object, right? Which means that memory had to be allocated for keeping the state information of each of these neurons, and you could be doing an operation on them, and then the new value had to be stored. So you are doing a lot of file processing in order to build these neural networks. Today, the neural networks are built in hardware itself, just like a RAM chip. Right? It's pre-programmed as a cell. So searching through that or using those chipsets to build deep learning networks is much, much faster today, of the order of several orders of magnitude more today, right, than what it was. What we are able to do is now we are able to bring in, essentially our senses of vision, smell, sound, right, speech. We are able to now integrate all of that into this smart device that we are building, right? Even today, we are not able to bring in. We are able to bring in some amount of taste and touch as well. Right, we have haptic displays. Most of your phones are touch sensitive, right? So we have some sensors to work on those sensors as well. But we are able to replicate all our senses using these sensors, and the next generation of these IoT devices are taking inputs from all these sensors in order to arrive at their decisions, right? I'll take this opportunity to kind of quickly go through the final section, which is in terms of what does it mean for you, how to avail of the opportunities that the IoT technologies kind of bring on to the field, right? Now, unlike your traditional computing systems where you had the technology stack in a particular computer, the IoT technology stack is more horizontal in nature. As you have realized that there are different kinds of devices with different capabilities, right? So if I look at the IoT technology stack, it is not a vertical stack, it is a horizontal stack, right? Which means that you have your phones which have you can push applications on top of it, but you have native Android APIs that allows you to use the sensors which are available on the phone itself, right? You have web servers which are able to serve you HTML pages. You have the mobile backend which allows you to work over HTTP, or what we call a REST interfaces, right? To do your third-party integration. This is a pretty well-known system because most IT systems are operating in this space. What is new with IoT is that now you are having low-power communication protocols that have evolved, MQTT, constrained application protocols like HTTP, right? These are the new protocols that are being adopted in the area of IoT, right? You have MQTT interfaces to the IoT gateways. These gateways are talking over C-based APIs to the radios, right? These are programs which are directly doing register read write from the sensor, from the radio transceivers, right, and communicating that to the networking stack over here, to the application over here, which in turn is communicating data over low power radios, right, like 𝐶SEN, wireless for smart utility networks, or ultra wideband, or LoRa, low power long range radio, or Sigfox or narrowband IoT. These are the new kinds of radios that are being adopted for communication between the sensor devices and this IoT gateways, right? And there again, you are finding this IoT, the devices itself, where there is a lot of role for people coming in from an instrumentation background, from measurement theory background to design these new kind of sensors. To people coming in from electronics, from electronics background, who would be needed to design these low power microcontrollers, microprocessors, if you will, right? And bring them all together into these IoT devices. So there is a role for pretty much every kind of engineering discipline to come in and contribute. You have the domain experts, people who are electrical engineers, trying to build these, trying to build these solutions for smart transformers, for smart electric meters, for monitoring systems on solar panels, monitoring systems on wind turbines. Right? So you have a lot of IoT-based applications being built for people coming in from electrical background. You have people, you have bridge monitoring solutions. You have concrete setting time monitoring solutions for people who are coming in from a civil background. You have IoT-based systems for monitoring conveyor belts, for monitoring various production parameters, quality control for people coming in from a production engineering background, right? So no matter what background people are coming in for, IoT has an opportunity for every one of them, right? So that allows us to say that, what is the future of an IoT engineer? If you look at the IT industry, the IT industry has grown from about 600 billion in 2019 to about, it is expected to grow to about $1.1 trillion by 2025. Right? And this will grow. The IT industry, with the digital transformations that are going on, the IT industry will grow very, very robustly. But the IoT industry is going to grow from 200 billion to $1.6 trillion. That growth is massive, which means that the new kind of companies that you will find which are building these IoT products, they are going to come in by the dozen, and they are going to grow much, much faster. Which means if you are going to join one of these companies, right, you are joining at an early stage, and your ability to grow along with that company is much, much more, right? You get a first mover advantage because you're joining it early. You have better entry level compensation because these are startups. They are trying to attract talent, and you have the ability to grow inorganically rather than going in the regular path of a software engineer, a senior software engineer, an associate software engineer, a team lead, a senior team lead, a project manager. That role in a services company, it allows you to take ownership of a particular product and go ahead and build it for a company, right? It allows you inorganic growth and higher visibility. And it allows you to work on disruptive technologies, on things that are adding fundamental value, right? Would you rather be working on building an application that shows a plant when every time somebody goes into an ATM machine and withdraws cash? Or would you actually be wanting to build a solution that creates a specific model for high-yielding lettuce plants that can grow in hydroponics, in water, and can be grown in people's homes, in people's verandas, right? That's an IoT-based solution. It does not take you away from the core. It retains your ability to work in core areas. And while you are learning all these technologies, note that you are still preserving your current mainstream opportunities, because you're still going to be developing a lot of front-end applications. You're still going to be developing a lot of mobile applications. So it does not take away from those IT jobs that are there, right? But it opens up new opportunities. It opens up new opportunities as not only software developers. It opens up opportunities for field engineers, people who would be going and deploying these solutions. It opens up scope for IoT prototypers who would be able to bring in the sensors and build quick and dirty product concepts, right? Quickly bring them together, who would be willing to get into the communications part of it, get into IoT research, right? People who would want to become IoT solution architects, to understand what is the pricing of such an IoT solution, people who would want to get into the product management of IoT companies, right? So it opens up a lot of different avenues, different roles, different career paths for many of you, right? So this is definitely an area that I would strongly encourage all of you to look into. I know that there is a center of excellence at your college, and that is already setting up a lot of infrastructure. Leverage that. Use that to do your projects so that you can come up with innovative solutions. Either it is if you want to use that to showcase a paper that you are working on, you want to get it published at a conference, or you're building a prototype that you want to incubate and grow further into an organization itself, right? Become an entrepreneur by building this product. A few days ago, one of my students came over, and we were discussing a particular project that he wanted to do. And after discussing with him, I found that he was, one of his uncles owned a potato cold storage facility. Right. So he started building a solution around monitoring the temperature within the cold storage facility. And this came out as a good solution. So he said, okay, can I make a few more copies of this and start putting it in other people who also own such potato cold storage facility? And now that is starting to form a company by itself, right? It's allowing him to solve a problem that was hyper-local, right? It's allowing him to build a company around this idea, right? And that is the future of an IoT engineer. Many of you may not want to get into building your own product or building your own company. For them, there are a lot of companies which are hiring for IoT engineers, whether these are semiconductor companies. All of the companies that I've listed over here are multi-billion-dollar organizations which are actively recruiting, right? You have companies like NVIDIA, ARM, Samsung, Analog Devices, Intel, which are working on the chipsets, on the semiconductor part of it. Right. You have companies like Vodafone, Jio, Tata Communications specializes in LoRa-based networks and Wi-Fi-based networks, right? So they have large smart city deployments. Airtel is working on narrowband IoT. Airtel and Jio, they are working on narrowband IoT as part of their 5G rollout. Sigfox is working on deploying a very, very ultra-low power communication network for these IoT devices, right? You are seeing the large cloud providers coming and recruit for IoT solutions, right? They have specific IoT gateways. Google has it, Azure has it, Amazon has it, right? So the cloud companies are looking for people who are going to deploy solutions on their platform, right? Then there are solutions companies like Bosch, Cisco, Ericsson, Siemens, who are integrating IoT into their products. So now they have a connected product that they're offering in the market, right? Whether it is in terms of a connected lathe machine or a connected food processing equipment, or it is a connected motor or a connected generator, right? So that's the kind of connected solutions that they are bringing in, right? Bosch is very active in the consumer market. Cisco is active in the networking and the smart city segment. Siemens is very active in the industrial segments. Schneider is active in the electrical segments, right? All of them are large companies, and I've just listed a few. And then there are solution engineering companies which are going to use all the components and build the control room applications. They're going to build the front-end applications for these solutions. And you have all the IT services companies taking up those roles, whether it is Infosys, the Mindtree, Happiest Minds, Wipro, TCS. All of these companies are opening up digital transformation solutions, right? By which they're capturing the data and making it available to their particular customers, right? So that kind of brings me to the end of today's talk. The theory part of it, or whatever I wanted to address on my side, please feel free to put in your questions on the group. Otherwise, I will take in those questions as they come along, right? If you liked our talk, please go ahead and give us a like on our social media handles. It means a lot for us. We are a startup organization ourselves, and this visibility is very, very helpful for us as well, right? With that, I'll hand it over to probably Professor Jyotish to kind of coordinate the questions, right?
Thank you, sir, for your valuable speech related to the innovative idea that IoT, especially the smart street light, what you talk about that. Yesterday, while we are taking the classes also related to an artificial intelligence, we started to give about the what is the starting scenario you told about. We want to switch on the lights when there is a sunny is available. In what way we can able to calculate the lighting intensity, all this thing. That is a startup I given. That is what you given the IQ or 0 over there actually. Yes. And
Yes.
yeah, so and the step by step what you told about the renewable sources and started with the location visualizations and the remote controls and predictive maintenance and context awareness, and as well as the speech and voice recognition to be integrated with the system, and as well as finally ended with the gesture recognition and as well as some of the AdSense to be added for the street light system. So this is what the smart system is really, whether the product is being launched or this is an idea focus on the development.
Oh, no. This is not this is just a step-by-step idea in how to build a smart product. I was just using the street light as an example. Okay. I'm just using the street light as an example because I can show the gradual increase in its IQ level, right? I can, the same applies for whether you're building a smart transformer or whether you're building any other smart device, right? There are always these, when you're building a product, you think through what are the additional value adds that we can build. I'm just using that as an example for students to also, rather than saying that I have all these things in a particular product, I just wanted to take them step by step.
Yeah, because while we talk about the artificial intelligence related to an IoT, as we know that there are different kinds of agents available, like a simple model or utility on goal-based. The product, what you've shown over, it simply started with a simple agent as a system, mildly to the model, and then go for the goal, and finally ended with the utility-based agents, which will make the user happy while they have been connecting with the Bluetooth or know about the awareness related to the ads and other things and all. I think the students are in the conference hall. They want to have an interact with you, sir. So yeah. So I asked the students to put over the information in the chat box.
Absolutely.
Yes, sir. Thank you, sir.
So the first question that I got was, how can you protect IoT devices from hacking? And I tend to get this question quite a bit in terms of what are the security aspects of IoT-based solutions, right? Now, when you talk about security, security comes from two areas. One is security of data in motion and security of data at rest. Right? First of all, you have to understand that many of these IoT devices, or most of the IoT, the large class of IoT devices, they do not talk Wi-Fi. They are not on IP networks, right? They are on 6LoWPAN, which most of your laptops will not talk. They are on radio standards, which most of your computers will not work on, right? So trying to get into a machine, into one of these devices from your laptop may not be possible. But there are consumer electronic products which are, smart bulbs and all, which are based on Wi-Fi, and you have that. First thing you do is you bring in security through what we call as the AAA, right? So you ensure that access to a particular device is post-authentication, post-authorization. So you know that a person has signed on. When they sign on to a device, they sign in on the cloud side. They are going to sign in on the cloud side and use your credentials to first gain access to the cloud system, right? From the cloud system, the user never really talks directly to the device. The discussion is mediated by your cloud infrastructure. Even then, the channel between the cloud and the end device, in HTTP, we use something called TLS, right? So many websites, when you get into, you will find that it has HTTPS, right? An SSL that is available over HTTP. Now, we cannot run a full-fledged SSL over many of these IoT networks, right? So there we use a lower version or lower powered protocol called DTLS, right? Which is used to create a secure transport layer between the IoT device and the field gateway, if you will. Right? That is one way of doing it. So physical security is the first form of defense, that you're not allowing anybody to talk on the same radio or any of that. The second thing is, even if you're allowing somebody, then you do it with proper authorization and authentication. Third thing is a secure transport layer that you can create. The fourth thing, it goes a little bit deeper into the device itself, where if you really need to protect that particular device, right? If it's a smart bulb, people are getting in, so what? Doesn't really matter. But if it is a really important thing that you must protect, you have something called a TPM, or Trusted Platform Module, that gets built as part of the hardware itself, which is going to store your credentials for communicating on the internet, right? And communication to the TPM is going to be restricted to only a few root level processes that can run on the microcontroller, right? Otherwise, those credential updates will not be supported. Fifth point, many of these IoT devices are being developed on a new protocol called lightweight M2M in order to ensure that there is interoperability and standardization. So lightweight M2M allows you to define what are called security objects, right? Which will kind of allow you to configure your network access credentials, right? Network access certificates, and without those certificates, you cannot join the network, right? So these are separate ways. When you are putting together a particular solution, for example, in this case, we are talking about a smart streetlight solution, you take into consideration what is the degree of security requirements that you have in a particular application, and weigh the costs of implementing a particular security countermeasures, right? Because at the end of the day, it's a software system, people can break in. How much you want to protect depends on how much you have to protect, right? Does that answer your question?
Thank you, sir. I think the next question the student has been posted. What is the, which programming language is easy to code in IoT projects?
So, as I mentioned, in an IoT system, unlike traditional systems, IoT is a horizontal stack, right? So it boils down to which part of this stack you want to work on. If you are working on the devices, it is going to be mostly C-based program, right? If you are working on these gateways, the gateways typically, so it's going to be, in the embedded part, you will either work with C, or you will work with special variants of C, which will be supplied by a particular chip manufacturer, right? If you're working on the gateway typically can have a real-time operating system, or it can be a bare bones, bare metal system, or it can be a it can have a proper operating system as well, right? In which case, if it has an operating system, then you are working in the user space, not in the kernel space. In which case, you might be able to deploy Node, you might be able to deploy Python, you might be able to deploy Java environments on these machines. So typically, the IoT gateway will have 1-2 GB of memory. They are not as memory constrained, right? So here you can use any of these programming languages to build your solutions, right? If you are working in the cloud backend, you will have a full virtual machine. You'll have full virtual machine. You'll have access to REST APIs and all of that. So here you can use MATLAB. Here you can use Python. Here you can use any of the high-level languages that are available to you. If you are building on these web servers, typically you are building on Node.js, on Python, on Ruby on Rails, PHP. So that's the kind of full stack application. If you're using this, if you're building an application over here, you are using a full stack methodology. If you are building a mobile app today, you want to minimize the number of applications that you want to support. So tools like Flutter and all are going to come in very, very handy. Or you can build this as a responsive app, or you can get into native development as well, right? So it is spread across where you want to build your solution.
Sir, what is a popular software IDE used in IoT? That is another question.
So mostly, I mean, I would strongly recommend using VS Code. I mean, I find that very useful because VS Code by itself supports Python, HTML, Java, all of those things. So VS Code kind of an environment will support this entire structure, right? But if you are getting into the embedded systems, right, then your particular vendor will give you an ID because you don't have an environment to get into here. So you'll have to write your code in C, use a cross compiler to build a binary for a particular device, and then transfer over the binary using a JTAG interface. Right, so it can be Code Composer or depending on whether if you're using, for example, if you're using ST devices, ST microelectronics, they can give you your own ID for that. So each company in the microcontroller environment, the particular vendor will provide you your ID.
Sir, in recent days, I heard the term like an LoRaWAN. Can you, yes, sir. Can you able to? What is the specific objective of that particular component?
So LoRaWAN, what happens is, in many cases, what happens is the communication that is happening from the sensors, right? It may not require a lot of data to be communicated. Right. If you do not have a lot of data communicated, now most of the protocols that you have today, the Wi-Fi, Bluetooth, is meant for high bandwidth applications, right? You are downloading videos over Wi-Fi, right? You can pretty much stream a song over Bluetooth at low ranges, but in many of these applications, say for example, the street lights, you might want to connect, you might have 1 lakh devices, and all of these devices, they don't send a whole lot of data. They may send one piece of data per day. They may send one piece of data per hour. So it's a very low bandwidth communication that is happening. LoRa is a technology that that gives you a very long range. In open space, one LoRa antenna can give you a range of close to 50 kilometers. Right, that's a huge range because the devices that are going to be there are going to send data very sparsely. Right, so only a few antennas can give you coverage over a very large network, over a very large area. Right. With LoRa, again, there are, so LoRa kind of defines the physical access mechanism, the physical layer protocol. And on top of that, you have LoRaWAN, which is the wide area network protocol is also defined. So if you are installing a LoRa server and LoRa radios, right, they will be able to communicate over very long distances and will be able to send data. LoRa supports both bidirectional. If you keep it as unidirectional communication, it will give you a much longer range. But if you keep bidirectional communication, it will reduce the range, but it gives you that window to send over a control message. Right? You get a LoRa server at your base station, and that server will now give you a device ID and the message that has been sent across. Right, so you get like a mobile base station. You install the LoRa the LoRa server, and from there on you can communicate over to the internet. Companies like Senra, companies like Tata, they have already deployed this network throughout India. Right, and when you buy a subscription from to an HTTP API from Tata, right? And data from you will get a JSON message with your data from that infrastructure itself, right? That's the main advantage. What I described is called a public infrastructure. In many cases, LoRa also allows you to deploy your own hardware in a private infrastructure mode. And that is very good when it comes to industrial internet, where you have a large, maybe a 2-3 square kilometer kind of an area of industrial plant, and you want to control all your networks yourself within the kind of range that you have, without having to bring in a third-party service provider. Right, so that's the main advantage of LoRa. Low power, it's a low power, long range radio, wide area network. right?
Sir, there is a question from our principal. What
Yes.
is a sustainable IoT and AI? And he
So
also mentioned about a difference between event-based outcome in IoT and activity-based outcome in IoT intelligence.
Right. I'll take the second question first, right? In terms of sustainable IoT, what you are finding, what we are figuring out is, IoT is getting used to control a large number of systems, right? This comes from renewable energy. You have systems in, solar power monitoring, whether it is wind turbine monitoring. So you have a lot of renewable energy sources which are equipped to deliver better output with IoT-based solutions. The next thing is in case of agriculture, right? In case of IoT being used for a lot of agricultural solutions where you are closing the loop, you are able to create models which allow for a particular crop to grow better, right? IoT-based solutions minimize the wastage in a particular environment. Let me go back to this particular slide where I talked about something as simple as a smart lighting solution, a smart street lighting solution. But in the process, all the wastages that are there, people going in and surveying a particular space, right? Where should this lamppost be put up? Right? That is again what we call is transportation cost, right? People are having to go there and look at things. That cost is getting minimized, right? Reducing motion. I now do not need people to actually move around as much because the communication is going over an IoT network, right? The number of people who are going around collecting information from various houses on their meter reading, right? I can reduce the effort that is spent towards it, right? So this is how we, in an overall system, we are bringing in more synergies so that my net cost of operating the solution is far lesser than what it was before, right? I'm able to, instead of glowing switching on the street lamp at full blast all the time, the fact that I can now reduce the energy consumption and yet provide a certain level of safety that is expected of the system. I can meet this twin challenges, right? That is where sustainable IoT is coming into the picture. Right? It is helping, provide the same or better quality of service at lower energy footprints. Right? Hope that answers your question, Professor Iyer.
Yes, sir.
Right? The next question, the question you put in is to differentiate between event-based outcome and activity-based outcome of in IoT intelligence. That's where when it is it boils down to the kind of rule engines that we deploy, right? The first, many of us in our, in the early programming, the first time we got into branching code, we talked about if-else structures, we talked about case structures, right? Pretty soon you find that, many of the IoT rule engines are written as if-else conditions, and we call this IFTTT, if this, then that. Now we started bringing in temporal or time-based events as well, right? So if this within a particular interval, if this given that something else has also happened. So then we started getting from simple rule engines to complex event processing. Along with complex event processing, we are now starting to see spatiotemporal and temporal activities also being combined with the rules itself, right? Now we are seeing, along with that, what is an event? We are starting to see video, gestures and intents also starting to come in. So it is no longer just a data, right? It is moving from beyond data to information, and from information to knowledge. It's going up that hierarchy. So we are starting to see knowledge-based decision making. That's where it is coming in terms of, rather than activity, it is becoming event and intent driven.
Thank you, sir.
Any other queries from the students' aspects? Thank you, sir, for your wonderful presence, and make this day to be one of the remarkable day in our college, as well as the students can able to learn about the really it is an intelligence in IoT that what you told about the smart street light, the projective way it start from the IQ of 0 to the 10, that what way you progressively taken about like how the visualization to be adapted, how the predictive maintenance should be made, and how the context awareness as well as the speech and voice recognition to be adapted with the gesture. So I think all these kinds of aspects given a broad idea about an IoT related to how the stack development, what are the different aspects of the companies which is being involved over there, and especially which each and every companies what their focus related to. You told about like a Cisco will be focused on network devices and the development of an systems. So I think the students as well as the faculties really got an opportunity to know about the intelligence in IoT, in what way the projects can able to make over it. And what we discussed that we will project this particular activities, especially in the name of little bit of product development, or how we can able to serve to the society what we have been applied over there with the name of an center of excellences. What we have already have one center of excellence with the name of an center of industry-based IoT applications, like how the industry-based IoT application can able to develop and take a little bit of product to the society. So that itself a great initiative. I think we expect your supports and your valuable guidance in the future to make progressively in our area, especially in the field of an IoT. So now I request our principal to make any few words related to the program. Please, sir.
Sir, good afternoon to everybody. The program was excellent. Sir has Professor Atanu Roy has very clearly mentioned about the IoT's excellence and sustainable aspects, history and information of designs and developments, Internet of Things, smart cities, field devices, data storage, programming, frameworks, MLAS, predictive maintenance, failures, along with the IQ meter reading rising from 0 to 10, and the activity as well as the event-based outcomes. This also I have learned, as well as combination of this activity and event-based also I would like to add, which is a process-based IoT as well as product-based IoT, combined based IoT that will be very useful for the life cycle assessment, life cycle development. That is, energy can neither be created nor be destroyed, but may be transformed from one form to another form. Mass also can be neither be created nor be destroyed, it may be transformed from one form to another form. That is a life cycle assessment, which is a very important that you have mentioned about the wastage minimization in the street lighting. And the scorecard of street lights, excellent. It was very, very informative. And the traffic status collaboration with the district administration, context awareness, speech and voice recognition, and the gesture and internet recognition, context aggregation, and they were very useful. And we are not aware of all these things even in book also. And this is very, very useful to sustainably automating future. So with this future sustainable automating that includes of the robotics and automation, sustainably automating future that is a sustainable development that meets the needs of the present generation without compromising the ability and the efficacy of future generations to meet their own needs. So with these few words, I thank you very much for elucidating the IoTs and sustainable intelligence excellence. So I wish this particular organization should achieve the center of excellence and center of potential for excellence, as well as center for skill development, that to green skill development in IoTs. So with this, thank you very much.
Thank you, sir. I think it was my pleasure to deliver this talk today to the audience, and I'm really thankful for this opportunity on behalf of the entire team. I definitely want to thank you, Professor Iyer, Professor Jyotish, for organizing this event, for getting in touch with and coordinating all the activities together. Professor Satyasilan, right? I not notice if he was still there with us in the talk, and of course Professor Kumaran and the rest of the management at Arunai. It's been wonderful to be a part of it, and we hope to look forward to bring similar discussions. Please note that all the topics that I presented today are open for projects. Right, all of them are project ideas. All of them can be areas that can be explored. Right, these are not None of them are copyrighted. So all of these are areas worth exploring by the students. Right? Go ahead and explore the potential. Right?
Thank you, sir.
Thank you.
Thank you, sir.